On to number 7. Break these apart first. Calculate the components in any of the cardinal directions. Of course, they'll only have components if that direction is listed in the description. Whenever you see something like northeast like this, that means 45 degrees along the side. So this is really the same as we were doing in number 1, except now we're attaching the cardinal directions to it. So I've got my brief description down here for A. Draw my 3.2 meters per second northeast, which is at a 45 degree angle. North is my opposite side, meaning I'll want to use sine. East is my adjacent side of the triangle, meaning I want to use cosine. And I get the same result because it's at 45 degrees. B, 1.1 meters west of north, 12 degrees west of north. Here my west is opposite side, so I used sine to find it. North is my adjacent side, meaning I used cosine. So I got 1.1 meters per second north, 0.23 meters per second west. C and D are actually the same. I just described them differently. The angle is described differently, but ends up being the exact same angle. We've got my 0.7 meters per second at, in this case, 62 degrees south of east. So my easterly component is adjacent side, so I use cosine. Southerly component is the opposite side, so I use sine, and I get 0.3 meters per second east and 0.62 meters per second south. That's 0.33. Down here for D, I'm using the complementary angles, and because of the way I drew the triangle now, east is the opposite side, so I use sine. So the sine of an angle is equal to the cosine of that angle's complement, so I get the same two results, even though I've had to flip the trig function I use. That gives me some totals up here. If I total my northerly directions, I get 3.4 meters per second north, 1.24 meters per second south. Should have done this ahead of time. 3.0 meters per second east, because this would add up to 2.96, but we can only have one decimal place, so I rounded that to 3, and 0.23 meters per second west. In order to find the total north-south component, I take north minus south, which gives me a total of 2.2 meters per second, and east minus west, which gives me 2.7 meters per second. The way I did it here, I didn't add them up and round, so that rounded to 2.7. If you're that close where rounding these is going to make a difference, your answer is going to be just fine. Here's those two drawn out. 2.2 meters per second is my northerly component. 2.7 meters per second is my easterly component. And again, I've used r for my resultant vector and theta for my angle. Find those the same way. Sum of the square root of the sum of the squares, Pythagorean theorem, to find 3.5 meters per second magnitude, and the inverse tangent of my opposite side over my adjacent side, which is 51 degrees. And again, depending on how you draw the triangle, you could get either result. I found 3.5 meters per second, 51 degrees east of north, but 3.5 meters, 39 degrees north of east is also a sufficient, adequate answer, good answer, correct even. That is all for this set of solutions.